Alright, so welcome back, y'all. Today we're doing inorganic chemistry. Class 11, Chapter 3, Classification of Elements and Periodicity and Properties. Yeah, anyway, so before starting, I'd like to introduce our new 4 members, new 4 subscribers that we've gained. So I have names for y'all. So welcome Thompson's Plum Pudding. Yes, and welcome Neurotransmitter. And welcome Cosmic Potato. And also welcome Schrodinger's Dinosaur. Yeah, thank y'all for being a part of my channel. And yep, let's be successful in this journey, right? So before starting, I'd also like to tell you that for this chapter, I have, actual for chemistry, I've made 3 categories. Smash, you already know what Smash is. For hard questions that, we kind of get stuck at them a little. So pass, really easy, simple, just pass. And third one is hard Smash. This category is for questions which are either really, really, good, very conceptual, or they have an exception factor. For, in chemistry, there are a lot of exceptions. Yeah. So if there's any exception, even if the question is super easy, but if there's exception, I'm going to put them in hard Smash category. Anyways, let's start, yeah? So I've actually done it till question number 32. Yeah, I've done it. And then I checked there are a lot of left. So I thought, why not? I was enjoying myself, but I thought, why not drag y'all too? So let's start. Okay, question number 33. Let me erase all the bullshit first. Yup. Okay, the correct decreasing order of metallic character is... Come on. We all know this. First, by the way, for trends, if y'all are struggling to, memorize trends, in memorizing trends, or if you're struggling to remember them, well, I have just a thing for you. My next video will be on that, how I memorize and how I keep, how I always keep the trends memorized in my head, right? I'm sorry if I stutter a little. I have ADHD also. So anyways, by the way, I forgot to introduce our little member here. It's his first time in this video, so be nice. His name is Salad. Ain't he cute? Alright, so we know that metallic character decreases across the period and increases down the group, right? We know that. So sodium, let's just make the row sodium, and then magnesium, then beryllium is above magnesium, we all know that. And then we have silicon, let's put, oh, y'all can see the answer. I'm sorry, I forgot to hide the answer. Actually, I'm not really focused on the answer. I just never cheat, okay? So beryllium, magnesium, and silicon. And let's see, we have silicon is on that side of the periodic table, right? It's in group 16, right? I guess. No, in 15, I guess. I don't know. And phosphorus we have. So these are on there, so their metallic character will be very less. For phosphorus, it will be the least, because it's, And for silicon, it has 16, right? Atomic number 16, so it will be a little higher than, it will be a little less metallic than phosphorus. Less metallic, okay? Not less metallic. So it will be second lowest, so that's true. And beryllium is on top, it increases down the group, right? So here, it's on this side of the periodic table. That means it is pretty metallic, but it's not more metallic than magnesium, so yep. And then comes magnesium, and then comes sodium. Yep, this order is perfect. It was really easy. I'm not gonna give it a smash. It was really easy. Y'all just need to remember the trends. That's it. Which I will make a video on. Alright, so yeah, which of the following pair of molecules contain odd electron molecule and expanded octet molecule? Wait, what? Odd electron molecule and expanded octet molecule. Expanded octet. Don't you think this question doesn't belong here? Well, I don't think it does. It's from what was that chapter? Just chemical bonding and molecular structure. Yes, it's from that chapter. I remember the expanded octet rule and stuff. Yes, it's from that. I can swear on my life it's not from this chapter, because I have studied this chapter really nicely. So yeah, let's just put a cross on it. We'll not do this. Okay, I'm not gonna show the answer this time yet. First ionization enthalpy of sodium, magnesium, and silicon respectively are this, and this. First ionization enthalpy of aluminium, whatever, however you say it. Well, we know that first ionization enthalpies increase across the period and decrease down the group. Okay, if you're struggling with trans, just wait for my next video. Okay. Yep. Yeah, where were we? So we have sodium, magnesium, and silicon is like on that side of the periodic table. So silicon will be of the the highest ionization energy. So it will have the highest ionization energy. So it's 496. I don't think something is right here. Oh, yeah, it's for sodium, not for silicon. I thought, okay. For silicon is the highest, yes, as I thought, as suspected. And, aluminium comes after magnesium if you have... See, y'all have to just remember the periodic table, okay? Or you can just sit with the periodic table in front of you and then you can judge and all. But right now, I have memorized periodic table, so I do not struggle. Y'all are pretty smart. I guess y'all have done that too, right? So it will have less ionization enthalpy than magnesium, but more than silicon, of course. So that will be around, that will be not 487. That's less than silicon. No, 768. That will be more than magnesium. 557. I guess 557. So y'all don't need to, come on. This was such a past question. So easy. We don't need the answer key for this. We know. For sure. Okay, which pair of oxides is acidic in nature? Ooh, so first of all, I highly recommend this book. It's really, I can really see the pages in my head from which these questions are from. So, which pair of oxides is acidic in nature, yeah? Oh shit, oh my god, I again made the answer visible, but we still haven't seen anything. Okay, just forget it. Okay, which pair of oxides is acidic in nature? Well, we know that acidic character, acidic character of the oxides increases across the group and increases across the period and decreases down the group, right? So, boron oxide, BO3, which pair? And CaO, well, calcium is on this side of the periodic table, so I don't think it will be much acidic. And silicon and boron and nitrogen, yeah. Boron is on that side, but it has 3 oxygen. And NO2, we all know NO2 is neutral. It's not acidic. And I think it's B, because silicon is on that side, and it has 2 oxygens. More the oxygen, more acidic it is. So I'm going to go with B. And let's see. What did I say? Pass. You know what? I'm going to put it in smash, because, these kind of oxide and acidic and basic nature kind of questions, these fuck you up real bad. Yeah. I'm going to put it in, not hard smash, but smash. Yeah. Alright, next question. Okay. Okay. Options and D. Okay. No answer is visible. So, what shall I say? First is, let's just name them, okay? I'm not comfortable with these configuration. First is 2 to 4, that's beryllium. First is beryllium. And B is 1, 2, 3, 4, 10, neon. C is, of course, 1 less than neon, that's fluorine, 9. And then D is 1, 2, 3, 4, 5. What's it, 5? Boron, right? Don't tell me y'all haven't memorized the first 20 elements, come on, guys. Anyways, so as I was saying what was I saying? Sorry. I was about to get distracted from the topic. But let's just stay here, right? Yeah, so what do we have to do? There's energy given here in kilojoules per mole. And this is delta I, which is ionization enthalpy. Yeah, we know. And ionization enthalpy increases across the group and decreases. I keep saying that, increases across the period and decreases down the group, okay? I will kill myself at this point. So beryllium is here this side, so it won't have like much. Yeah, it won't have much ionization enthalpy. And what about neon? Neon is a noble gas. Oh, we know there was one exception related to noble gas. I remember it was something like except noble gas. I remember in this book it was something written like that. Fluorine, we know that in case there was one more exception, that the ionization and the electronegativity, the ionization enthalpy of the electron gain enthalpy. No, what was that? It was electron gain enthalpy is less negative. Fluorine is less negative, negative than fluorine. So this was an exception, yes. Okay, and for fluorine, and fluorine is on that side, and boron, right? So fluorine comes here, boron comes here. So for fluorine, it will be the highest, more than neon, because noble gas have exception, right? So I'm gonna go with fluorine at first. That means C at first. I mean the highest. C will be 4. C will be 4. B will be after that. And yes, we remember another exception, that beryllium comes after boron. This was the exception, I remember. Okay, y'all have to remember the exception. Okay, I'm gonna put it in hard smash. Okay, so I'm making it easier for you guys. It's purely based on exceptions, right? So beryllium will come after boron. So that means boron will have lower or beryllium will have higher electronegativity. That means A is 2. A is 2. C is 4. B is 3. What? B is second highest. And A is third highest. And B is, Wait, what's going on, bro? C is the second highest. First highest. C should be 4. And B is the second highest. So it should be 3. B is 3. A is the third highest. It should be 2. Yes. Okay. A is the answer. Oh my god, the answer was visible this whole time. What am I doing? Oh god. What did I do? Oh my god, it was easy, but this was full of exceptions. We have like 2 exceptions, 1 question. Come on. Can't miss that. Alright, yeah. Remember, this was a whole exception-based question, okay? No logic in it so much. We know that ionization energy increases across the period and decreases down the group. But in this case, it definitely chose beryllium over boron, even though it's left. And it's not following the trend, right? Consider the elements, this increasing order. First, okay, another ionization enthalpy question. So we know it increases, okay. Let's just write them down, Mg, and just below that, write Al. And then we know S and P, they come on that side of the periodic table. So just add some space and write S. Wait, it's sulfur, right? Sulfur, chlorine, and argon. Oh my god, I think I made a mistake of, oh my god. I think I considered silicon as sulfur somewhere in some previous question. Oh my god, please excuse me if I did that. Anyways, yeah, that's sulfur, chlorine. So sulfur, chlorine, and potassium comes in the first group. So I'm going to put it here. And then silicon, yep. Silicon is 16, right? No, that's sulfur. Silicon is not 16. What am I even doing? What's the atomic number of silicon? Okay, this was really dumb. Really dumb. Okay. This is basically a compilation of me making this most stupid mistake. Okay. Oh shit. Yeah, so potassium is here, magnesium and aluminium. Yeah, so these will have the highest energy. Sulfur will have the highest ionization enthalpy. Yep. Sulfur, it will be the highest. After that will be silicon. Sulfur, then silicon. Oh, yeah, the last will be phosphorus. Okay, there's no potassium. Oh my god, why did I write K here? Where did I see K? Okay, potassium is 19, so it will be highest. Then sulfur, then silicon, then aluminium, then magnesium. right? Yep, I'm gonna go with A. B, what? Sulfur. Oh, my phone just died, and
How?
I don't think. Also, I gotta go somewhere. Like, it's study related, okay? I'm not wasting my time. But also, one more thing. If you all want to join me, I have put my Telegram group link in the description. There you can be part of me, and like, we all can be a real team, okay? So, check that out.